Alright, this video is on the extended power rule. And the extended power rule is really an extension of what we call the chain rule. So let me write what the chain rule is first, and then we'll talk about the extended power rule. So if I was talking about the chain rule, this is what we use when we take derivatives of a composition, meaning derivatives of a function which is inside of a function. So the chain rule works like this. If I was to take the derivative, alright, with respect to x of f of g of x, right? So it's a composition, right? The g of x function is inside the f of x function. So it's a function inside of a function. The way you do this is that you actually take the derivative of the outside function, so we call this f prime of, you keep the inside the same, so f prime of g of x, and then you multiply it by the derivative of the inside function, which would be g prime of x. Now this is the general rule for the chain rule, and we'll talk about it throughout the course. But it's actually a little more beneficial to look at it at individual cases. I think it helps you understand the chain rule a little bit better if you look at it at the specific cases where it occurs. So the extended power rule, which I'm writing above, really is going to be, a variation of this. It really says for any real number. Right, so for any real number we'll call k. Right, so for any real number k, we'll have that if I take the derivative of some function raised to a power. So let's say the function is called g of x, and I'm raising it to the k power. We're going to treat this like we just talked about the chain rule. The derivative of the outside, keep the inside the same. Right, derivative of the outside, keep the inside the same, times the derivative of the inside. Well, in this specific case, the outside function is the raising to a power. The inside function is the g of x. So how do you take the derivative of the outside? Well, typically you bring the power down in front, right? So this is going to equal to k times, remember you keep the inside the same, so this is times g of x, and then you subtract 1 from the exponent, so it's k minus 1, and then you multiply by the derivative of the inside, so times g prime of x. So this extended power rule, right, is actually a special case of the chain rule. The derivative of the outside function means bring the power out in front, keep the inside the same, subtract 1 from the exponent, because that's what you normally would do on the power rule, and then multiply by the derivative of the inside. So we're going to use it throughout this section, and then once we do this, we'll look at the rest of it in terms of other sections, how the chain rule will be applied. So if I say to differentiate, and the first one I'll look at is if I had y equals 3x plus 7 raised to the 25th power. Well, I want to take the derivative of this. The thing you should notice is that you have a function raised to a power. What you can't do is you can't bring 25 as the exponent on each piece in here. That's not allowed because you have a sum in here. So you can't bring the power inside. So take the derivative of this. It's a function raised to a power. The inside is this piece, right, the 3x plus 7. The outside function is the 25th power. So when I take the derivative, I want the derivative of the outside, which means bring the 25 down in front, times you leave the inside alone, so keep that as 3x plus 7. Remember, derivative of the outside, you bring that in front, subtract 1 from the exponent, makes it 24. And then you multiply this by the derivative of the inside. That's what our chain rule says. That's what the extended power rule says. So times the derivative of 3x plus 7, which is just times 3. Now you can simplify this, and to simplify this, you can multiply the coefficients together here. So 3 times 25 will give you 75 times 3x plus 7. This is all raised to the 24th power. You can't distribute 75 into here because there's a power out here other than 1. The only time you could distribute in is if you don't see a power here, unless the power is 1. So this is it. This is the answer for the first derivative. Let's take a look at another one. If I had, call it f of x equals negative 7x squared plus 3, say raised to the 4th power. again, you should notice you have a function inside of a function, right? This whole function is being raised to a power. So we're going to use the chain rule. In this case, we'll call it the extended power rule. So the derivative, f prime of x is equal to, remember how it works, it's derivative of the outside, so keep the inside the same. So derivative of the outside tells you bring 4 in front. So you have 4 times negative 7x squared plus 3. The power decreases by 1, remember when you use that power rule? And then you multiply by the derivative of the inside. Well, what's the derivative of the inside here? Well, negative 7x squared, the derivative of that would be, bring the 2 times negative 7 is negative 14x to the first power. Derivative of 3 is just 0, so you're just multiplying by negative 14x. And then again, to simplify, you can multiply these together. So f prime of x equals negative 14x times 4 will be a negative 56x times, here we got negative 7x squared plus 3 raised to the third power. And you leave it like that. You can't distribute into that. And you also don't want to expand this. I mean, you'd be really making this kind of messy if you did. I mean, if you try to expand something like this, not as bad. Try to expand something like this with a 24th power. I mean, you might spend the entire day doing it. So you don't want to be in that scenario. So simplify, but you know, you can leave it as a factor to the power. Let's look at a few more. If I said I had g of x equals the square root of x cubed plus 6x. Well, looking at that, you do have a function inside of a function, right? You have this x cubed plus 6x, this polynomial, inside of the square root function. So we know we should use a chain rule. And before you use a chain rule, though, remember, if you see any roots in your problem, you need to rewrite it. So the first thing we're doing is a rewrite step. It's still called g of x. Don't change the name of it. And we're going to rewrite this as x cubed plus 6x. What's the power that's associated with the square root? Well, that's to the 1/2 power. So it's the same scenario we've had, right? We've got a function inside of a function. And now we're going to take the derivative using the chain rule. Derivative of the outside tells you bring 1/2 in front. Keep the inside the same, so you have x cubed plus 6x to the power of 1/2 minus 1. Remember, you subtract them from the exponent, makes it a negative 1/2. And then you multiply this by the derivative of the inside. Well, what's the derivative of the inside here? Well, the derivative of x cubed is 3x squared, plus the derivative of 6x is just plus 6. Now, once you're here, you know, in the previous problems I was able to multiply these together. Now, this one has more than one term, so you really can't multiply them in a traditional way. But, you know, we can simplify this. Looking at, if I said do not simplify, you could stop there, by the way. But if we wanted to simplify this negative exponent on this tells us that this x cubed plus 6x, when you move to the bottom, we make the exponent positive. 3x squared plus 6, this is in the numerator, so you should think of it that way, right? It's times 1. So we have 3x squared plus 6 over 2, and the denominator stays 2. And then the x cubed plus 6x to negative 1/2. The negative of the 1/2 moves it to the bottom. The 1/2 tells you to take the square root of it. So it's the square root of x cubed plus 6x. And this would be the simplified form. How about this one? I just want to show you a little bit of everything you might see. If I had something like y equals 3 plus x to the third to the 5th power minus 1 plus x to the 7th, that quantity to the 4th power. When you look at this, you should notice that you have more than one term, and remember, you can differentiate. You can take the derivative term by term. When you do that, though, within the term, you might have to do other rules. So when we take the derivative here, y prime, for this first term, 3 plus x cubed to the 5th, this is a function inside of a function. So that tells us we should use our chain rule. So I'll use chain rule on this, and we'll bring the 5 down in front. So you have 5 times the inside, remember, stays the same, and then the power becomes 4 because you reduce it by 1, times the derivative of the inside. The derivative of the inside of this, the derivative of 3 goes to 0. The derivative of x cubed is just times 3x squared minus, you still have that minus there, and now you want to take the derivative of this term. Well, this term is also a function inside of a function, so you have to use chain rule here. So it's minus, you want to bring the 4 down, times, you keep the inside the same, the power becomes 3, right, because you reduce it by 1, and then you multiply by the derivative of the inside. Derivative of 1 goes to 0, derivative of x to the 7th is 7x to the 6th. I think you can see that. It's a little tight there at the end of the paper. If I said do not simplify, you can leave it like that. But let's simplify this. You know, it doesn't simplify to, you know, something too difficult to get to. For this term, the 5 times 3x squared gives us 15x squared. This is still 3 plus x cubed to the 4th. Remember, you can't get inside of there. Minus 4 times 7x to the 6th is minus 28. X to the 6th, and then this stays 1 plus x to the 7th cubed. And really that's it. You've simplified it. You're not going to do anything else with that. Let's look at a few more, maybe a little more challenging. If I gave you this one here, so this will be letter E. Right, so remember, we're differentiating means taking the derivative, and I gave you h of x equals x plus 5 to the 7th power times 4x minus 1 to the 10th power. So, first thing you should notice is that this is a function times a function. So the first thing you want to do here is product rule. Within the product rule, you do have things here that are functions inside of functions, which would mean you use chain rule. But remember, you have a product first, right? It's this function times this function. So this is a product rule problem. Sometimes people get tripped up on this and they try to use the chain rule immediately, and you can't because this isn't a single term, right? This is all one big term that has 2 factors in it, so you have to use a product rule. So we'll use the product rule. So h prime of x, remember how product rule works. You take the derivative of the first function. Now within that, I'm going to use the chain rule, right? So the derivative of the first, the x plus 5 to the 7th power. We're going to take the derivative of the outside, so you bring 7 down in front, times you leave the inside alone, so it's x plus 5 to the power of 6 now, reducing it by 1. So, and you multiply that by the derivative of the inside. This is the chain rule on this first part. Derivative of x plus 5 is just 1. So this part here is my first part of my chain rule. This is the derivative of the first. Times, you want to leave the second alone. So times 4x minus 1 to the 10th power. Remember how the product rule works. Plus, alright, so plus, you want the derivative of the second, 4x minus 1 to the 10th. The derivative of that, you bring the 10 down. The inside stays the same, reduce the power by 1 to 9, and you multiply by the derivative of the inside, which in this case, for 4x minus 1 is just 4. That's the derivative of the second function, times you have to multiply it by the first, which was x plus 5 to the 7th. Let me just show you which pieces are which in case you got a little lost there. It's a lot going on at the same time. This, if you want to think about it in terms of how we describe the product rule, this is f and this is g. It's the derivative of the first. So this is f prime. This is g. You keep the second alone. Plus, it's the derivative of the second. So this is g prime times the first. So that's where we're getting these pieces from. We're following product rule, and then within it we had to do chain rule, and we had those derivatives of those individual pieces. Great. So if I say do not simplify, you'd be done. You'd stop right there. But I want to simplify this. I want to show you how it simplifies, just to make sure you understand how to do it. Sometimes people forget. So if I was to look at this, now it's all h prime of x. It's just simplified down. 7 times 1 is 7, so you have 7 times x plus 5 to the 6 times 4x minus 1 to the 10th. Plus here, you've got 10 times 4, so that'll be 40. And then maybe I'll write it in the same order of the factors I had it before. So I'm going to write x plus 5 to the 7th times 4x minus 1 to the 9th. And, you know, this isn't exactly simplified completely. If you look at it, you know, we can actually, if you have common factors, you could factor them out, which helps you write this in a more condensed form. So we do have common factors here. Now the 7 and the 40, they don't have any common factors other than 1, so I don't have to factor out a GCF from there. But if I have x plus 5 to the 6th and x plus 5 to the 7th, that's a common factor of x plus 5 that they have. And you want x plus 5 to the 6th. It's the one that is the greatest one, right? That's common to both. You can't take out 7 because there aren't 7 of them here to grab, but you can have x plus 5 to the 6th. And then here for the 4x minus 1 to the 10th and 4x minus 1 to the 9th, you can factor out a 4x minus 1 to the 9th. Remember, you want the lowest power you see because it's the largest one they have in common. And then you want to write what's left over. Well, after I factor this out, 7 stays 7. I took out x plus 5 to the 6th to the front. That divides that whole piece out to a 1, so that cancels. You had 4x minus 1 to the 10th. You took out 4x minus 1 to the 9th, so that leaves me with just 4x minus 1 to the first power. Plus in the next term here, 40 stays 40. X plus 5 to the 7th, I factored out 6 of them. There should be 1 left, so x plus 5 to the first power. 4x minus 1 to the 9th, you factored out 4x minus 1 to the 9th. That'd be just times 1, so we don't need it. And then what we'll do is we will simplify within these brackets. So you have x plus 5 to the 6th times 4x minus 1 to the 9th. And then simplifying within the brackets, 7 times 4x is 28x. 7 times a negative 1 is minus 7. Plus 40 times x is 40x. 40 times 5 will be plus 200. And then we'll simplify this. H prime of x equals x plus 5 to the 6th times 4x minus 1 to the 9th times 28x plus 40x is 68x. 200 minus 7 will be plus 193. And you've got it. The reason I wanted to simplify this with you is that sometimes, you know, when you go to check your answers, they're going to be in simplified form in the textbook, and you may not know how they got there, right? Because you would have done everything correctly up till here, but you might not have recognized how they got down to here. So having an understanding of how to factor out those factors is really important. Let's look at a couple more. If I said I had this function here, maybe I'll label it g of x. So if I said g of x equals the cubed root of x plus 5 over x minus 6. First thing I notice is that I have this root in here, so I want to rewrite this, right? So the first thing you should really do is rewrite this as g of x equals, remember, the root tells you what about the exponent. So you have x plus 5 over x minus 6, that's all inside the root. It now becomes a rational exponent. It's to the 1 over the root, which is 3, so it's to the 1/3 power. And so we want to take the derivative of this. Now, the derivative of this, we have a function inside of a function, so we're going to use chain rule. Don't think it's quotient rule. You might use a quotient rule within it, right? Inside of there, it looks like there's a quotient rule, but from the get-go, from the beginning, we have a function being raised to a power. It's a function inside of a function, so we're going to start with our chain rule. Right, so for the chain rule, right, this is g prime of x. It's the derivative of the outside. So 1/3 would come to the front. So we have 1/3 times, you keep the inside the same, remember, so it's x plus 5 over x minus 6 raised to the 1/3 minus 1 would be negative 2/3. And then you want to multiply this by the derivative of the inside. Well, the derivative of the inside, now you have a function divided by a function. This is telling you now use the quotient rule. So now we're going to use the quotient rule within there. All right, so now we're using the quotient rule. So the quotient rule says you take the derivative of the numerator, so derivative of x plus 5 is just 1, and you multiply it by the denominator, so multiply by x minus 6, right? So the derivative of the top times the bottom, minus, make sure you put minus there, the derivative of the bottom, the derivative of x minus 6 is just 1, times the top times the numerator is just x plus 5, and you put this all over the denominator squared, so it's x minus 6, the quantity squared. Now if I told you find the derivative, do not simplify, you can stop there. That's the derivative. And I might ask you questions like that just to make sure that you understand how to set it up. You know, getting to the answer is great, but if you can just copy the answer from somewhere and not understand how to get there, it's not going to help you. G prime of x. Let's simplify this now. So 1/3, I'll keep 1/3. A negative exponent on a fraction, if you remember, tells you to take the reciprocal of the inside, so you flip the inside, x minus 6 over x plus 5, and then the power becomes positive. It's the same as bringing the negative exponent to each factor and then moving them up or down in the numerator and denominator as appropriate. Multiplied by, well, what's this come to? If I simplify this, 1 times x minus 6 is just x minus 6, right? So I would have x minus 6. This is really like a negative 1 to get distributed through. So minus x minus 5 all over x minus 6 quantity squared. And we'll simplify this to, this is 1/3 times, here we've got, maybe I'll show it on each one individually. X minus 6 to the 2/3 over x plus 5 to the 2/3. Just having an understanding that when you do this, right, when you have a fraction, if you have a factor in the numerator and a factor in the denominator, you can bring the power in that way. You can't do it if it's just addition or subtraction between terms, but you can do it with different factors in the numerator and denominator. Times, here x minus x cancels, you're left with negative 6 minus 5 is negative 11 over x minus 6 quantity squared. Alright, so now we're just going to continue with our simplification. Negative 11 times the 1 in front gives me a negative 11/3. Sometimes it's easier just to see that right away, take care of it. You have this x minus 6 to 2/3 divided by an x minus 6 here. If you were thinking about where those factors end up, 2/3 minus 2 is what you would do when you divide, because you know when you divide things at the same base, you subtract their exponents. So 2/3 minus 2, which is 6/3, would give me a negative 4/3. So since that's going to be a negative 4/3, the x minus 6 would be to the positive 4/3 in the denominator. Right, this would be 6/3, that's 2/3. 2/3 minus 6/3 gives you negative 4/3. Negative tells you to move it to the bottom. And then you've got x plus 5 to the 2/3. That'll stay in the denominator, remembering that you know the exponent's positive there. So you could leave it like this. That's fine. You might also see it written with negative 11 over 3 times. If you're looking at this third and this third, right, means really cubed root. You could write this as the cubed root of, and this would be x minus 6 to the 4th times x plus 5 squared. And you could even go further than this with it, because if you have x minus 6 to the 4th and this is the third root, really what this equals is negative 11 times 3, and then x minus 6 to the 4th taking the third root. Well, 3 of them would give me, you know, the third root of 3 of them would give me an x minus 6 factor in front, and then you would have the third root of just x minus 6 times x plus 5 squared in here. I don't think I would ask you to simplify something like this all the way down. I mean, additionally, you could even rationalize this, right? Multiply numerator and denominator by the cubed root of whatever's in here squared to make that work. It would be a lot more to do that. For our purposes, I'm okay with you leaving it like this. You do not need to rationalize for this course. But you should understand how to get there. So if I ask you to do not simplify, though, right away, this one here, the first derivative you just took at the beginning, if you did it all properly, that would give you full credit. And let's just take a look at one more example. This is really, using it to, find the slope of a tangent line. So if I said, for example, find the equation of the tangent line to f of x equals 3x minus 14 raised to the 5th power at the point 5, 1. So first off, equation of the tangent line. The equation of any line, you need two things. You need a point and you need a slope. They gave you the point, right, but we don't have the slope. Now, they gave you the point 5, 1. That means the point on this function. If you were to check it, right, this is the x value. They might say just that x equals 5. If we just said at x equals 5, you should know how to find the y value by subbing into this function, right? F of 5 would be 3 times 5 is 15 minus 14 would be 1. 1 to the 5th power would be 1, and that's how they're getting that y value. So we already know the point, which is good because then we don't have to calculate it, even though we just did it out loud. I want to make sure you have an understanding of where it comes from. You also need the slope, we said. Well, what's the slope? The slope comes from the derivative. Now remember, I need f prime of 5 when I go to do it, but you have to find f prime of x before you substitute in the x value of 5. Sometimes people try to sub the value in right away, and then that will be a constant. So f prime of x, we're taking the derivative of this up here. Well, this is a function inside of a function, right? It's a function to a power. We're going to use our extended power rule, meaning the chain rule. 5 comes down in front, so we have 5 times the inside, 3x minus 14. Right, keep that as is, and then 5 on the exponent reduced by 1 gives you 4. And you want to multiply this by the derivative of the inside, so times derivative of 3x is just 3, derivative of 14 goes to 0, or negative 14 goes to 0, so just times 3. So f prime of x is really equal to 5 times 3 is 15 times 3x minus 14 to the 4th power. Now remember, we want the slope at a specific point. We want the slope at the point 5, 1, meaning the x value here is what I really care about. We're subbing in 5. So I need, right, so what do we need? We need f prime of 5. Well, this would be equal to, we have 15 times 3 is 5 minus 14, close that parentheses, to the 4th power. We end up with 15 times, 3 times 5 is 15 minus 14. This is really like 1 to the 4th power. So this equals 15 times 1, which is just 15. Now what is that 15? Make sure you know what you found. The 15 is the slope, right? The slope is 15 at the point 5 comma 1. When x equals 5, the slope of our tangent line is 15. So now you've got the point, right? You've got the slope. And now you have the point and the slope. We can use our point-slope form to get the equation of the tangent line. Remember, that was y minus y1 equals m times x minus x1. And we're just going to substitute in. So remember, y and x stay y and x. So it's y minus, what's y1? Well, y1 is 1. They gave it to us, but remember, you could have found that if you needed to. Equals m, which is 15. Times x stays x, minus x1, well that's the x value for a point we know, which is 5. And then we just, distribute through and solve for y, so we have y minus 1 equals 15 times x is 15x. 15 times a negative 5 would be minus 75. And then we'll add 1 to both sides. And we end up with y equals 15x minus 74. So this is the equation of the tangent line to this graph of f of x equals 3x minus 14 raised to the 5th power at the point 5 comma 1. When x equals 5, this would be the equation of the line that touches the graph just at that one point there. So, chain rule is, used in other areas of calculus. This extended power rule is one subcase of it. Later on in the course, we will talk about subcases that are involved in both exponential and log functions. You also will see this if you were to take other classes in trig functions.